What if an AI could learn about the world the same way a baby does? Not by reading the entire internet, but simply by watching. Well, that's the fascinating new direction in AI we're unpacking today.
I mean, really think about it for a second. A baby learns about gravity, that objects don't just vanish into thin air, and 1,000 other rules of reality, all without a single textbook. It's all just pure observation. For AI researchers, this is pretty much the holy grail, creating a system with that kind of intuitive common sense. The problem? That's not at all how most of our current AI systems work.
So on one side, you've got us. We learn pretty efficiently, building these powerful internal models of how the world works. On the other side, you have most modern AI, which is just incredibly data hungry. It needs millions of labeled examples, and still, often, lacks the basic common sense we all take for granted. But a new approach, called JEPA, is trying to finally bridge this gap.
To really get why JEPA is such a big deal, we need to quickly look at the two main ways AI has tried to learn on its own in the past. These are called self-supervised methods, and they pretty much fall into two camps: comparing and copying.
Okay, so first up is contrastive learning. The big idea here is to teach the AI what's the same and what's different. You take an image, you create two slightly different versions of it, maybe you crop it and change the color, and you tell the AI, hey, the core concept in these two pictures is identical. And at the same time, you show it other completely different images and say, and these are not the same. So the AI basically acts like a bouncer at a club that's only for identical twins. Its whole job is to find the matching pairs and make sure everyone else is kept separate. It's a powerful idea, for sure, but it has some real drawbacks. See, here's the problem with that approach. You have to be really, really careful about how you create those different views. If you're not, the AI might learn to just ignore important details. Plus, it's constantly having to compare against things that aren't a match, which, as you can imagine, requires a huge amount of computing power. So that was comparing. The second path is generative learning. This is the tech that powers a lot of the image generators you see everywhere these days. The approach here is totally different. The AI is trained to take a piece of data, compress it down to its essence, and then reconstruct it perfectly, pixel by pixel. This approach turns the AI into a kind of perfectionist painter. It gets obsessed with getting every single detail right, from the main subject all the way down to the random static on a screen or the exact texture of one single leaf. And this, right here, is its core weakness. And this obsession with pixels is just a huge waste of energy. It spends massive amounts of computation trying to predict details that are, well, unpredictable. This is exactly why these models sometimes make those really bizarre errors, like generating hands with 6 fingers. They're so focused on the pixel-level texture that they totally miss the high-level common sense rule that humans have 5. So yeah, both comparing and copying have some pretty fundamental flaws. And this brings us to a third way, a new paradigm championed by AI pioneer Yann LeCun and his team at Meta AI. It's called the Joint Embedding Predictive Architecture, or for short, JEPA. This quote really gets right to the heart of it. JEPA isn't about comparing different views, and it's not about reconstructing every single pixel. It operates in the realm of ideas, of abstract concepts. It's trying to predict the meaning of what's missing, not the raw data itself. So here's the crucial point. If a generative model is like a painter trying to physically fill in a missing puzzle piece, JEPA is more like a puzzle master who just looks at the empty space and says, okay, what goes here is the top of a dog's head in front of a blue sky. It doesn't need to paint the pixels, it just needs to understand the concept. So how does it actually do this? How does an AI learn to imagine the essence of what's missing? Let's take a look inside the engine. The architecture at its core is beautifully simple. It has 3 main players. First, you have the seer, or the context encoder. It looks at an image with a piece missing and just gathers all the clues it can find. Then, the guesser, or predictor, takes those clues and makes an educated guess about the concept of what's missing. And finally, the judge, or target encoder, holds the correct abstract answer and gives feedback to the guesser, helping it learn and improve. So, to put it simply, the context encoder sees what's there, the predictor guesses what's not there, and the target encoder knows the truth. Through millions and millions of rounds of this see, guess, check process, the system starts to build an understanding of how the world fits together. It learns fundamental rules, like the fact that dog bodies are usually attached to dog heads. And this isn't just a theory. When researchers visualize what the JEPA model is actually imagining, it's incredible.
You give it the body of a dog, and it correctly predicts the abstract representation of a dog's head. It fills in the missing legs of a wolf. It can even infer the hidden side of a building. It's not generating pixels, it's demonstrating a genuine, high-level understanding of the world. Now, this ability to imagine and predict is not just some cool party trick. It's a key piece of a much, much grander vision for the future of AI. The ultimate vision is to build AI that develops real common sense by creating its own internal models of reality. Just like that baby at the beginning, it would learn physics and cause and effect, and that things still exist even when they're out of sight. Not because it's told, but by constantly predicting what will happen next and learning from its mistakes. Imagine a robot that understands not just what an object is, but what will happen if it drops it. JEPA is the engine designed to make that happen. And JEPA didn't just appear out of thin air. It's built on decades of foundational research. This is really the culmination of a long journey, starting with Yann LeCun's pioneering work on convolutional networks way back in the 80s, which led to the formal proposal of this architecture in 2022. And finally, in 2023, with the release of iJEPA, this powerful theory became a practical reality. And the practical benefits are already stunning. Because JEPA isn't wasting all that energy predicting irrelevant pixels or constantly making comparisons, it's incredibly efficient. The first implementation, iJEPA, was able to train on the massive ImageNet dataset 2 to 10 times faster than similar methods. That is a huge leap forward, and it makes this kind of powerful learning far more accessible. If you take away just one thing from this explainer, let it be this. This is the paradigm shift. AI is moving from being a meticulous pixel memorizer to an insightful predictor of concepts. It's learning to understand the world by focusing on what truly matters, and that changes everything. Which, of course, brings us to the final, tantalizing question. This new ability to predict is a huge step forward, but is prediction the same as understanding? As these world models become more and more accurate, we're going to have to confront what it truly means for a machine to understand our reality. That's a question for the future, but JEPA is bringing that future closer than ever before.